When you look at massive industrial grain rollers crushing thousands of pounds of corn, it is easy to assume the goal is brute force, pulverizing the grain as fine as possible for the cattle to consume. But grinding grain is a highly targeted operation. A mechanical adjustment of a fraction of a millimeter on the mill floor directly controls what happens inside the animal's digestive system. The exact physical dimension of that single grain particle dictates how the microscopic rumen microbes function and ferment the feed. We can map this process on a biological spectrum. The target is the optimal zone in the center. Missing that mark and landing on either the too coarse extreme or the too fine extreme triggers two completely different types of systemic failure. A feed mill manager is actively engineering a microscopic ecosystem, using particle size as the control dial. If mill rollers are set too wide, intact kernels slip easily through mechanical gaps. Inside the digestive tract, natural enzymes bounce off the hard outer barrier. The highly digestible starch core stays trapped. The entire kernel passes through, leaving valuable nutrients unutilized. For a feedlot, this biological bypass causes a sharp drop in feed efficiency. The farm pays for calories that the cattle cannot physically extract, leaving money literally lying on the ground. Cranking the rollers too tight pushes a rising grain into microscopic dust. Inside the rumen, this massive surface area triggers explosive chemical fermentation. Acidity aggressively spikes upward into the red zone, a rapid, dangerous buildup called acidosis. High internal acidity disrupts the gut environment, causing cattle to stop eating consistently and severely compromising the health of the herd. To avoid both failures, professional feedlots calibrate their equipment to hit the green optimal zone directly in the center of the spectrum, yielding perfectly sized, uniform particles. These particles achieve a precise physical balance. They are small enough to maximize starch extraction, but large enough to keep the fermentation process steady and safe. Hitting this central target is the only mathematical way to guarantee healthy rumen fermentation while extracting peak nutritional value. Maintaining this biological balance dictates the daily operational procedures on the feed mill floor. Mills enforce strict daily protocols. Operators continuously monitor roller settings, test processed grain quality, and they inspect the roller corrugations to ensure they aren't wearing down. Every calibration of the steel equipment directly alters the chemical biology of the cattle. A perfectly maintained mill produces a consistent, ideal feed, supporting a thriving animal with a healthy, steady intake. Particle size bridges the mechanical precision of the processing plant with the physical growth of the herd, converting daily calibration into optimal performance.